We're going to do a little advanced scanning with Nmap here. So what I want to do is I'm going to do something called an idle scan. And an idle scan makes use of actually IP. In addition to doing some checking on TCP ports, because of course ports live at the transport layer where TCP is, we're actually going to be making use of the IP headers as well. In this case, we're going to be using the IP identifier. Now, the IP identifier is actually used to figure out whether packets are fragmented or not. And so I'm going to start this scan off. And what I want to do is actually want to save it in this case. And so I'm going to give this a file name, and I'm going to save it because we're going to load it up into Dradis just to have some record here. Now, the IP address I've given here is, this is the quote-unquote zombie host that we're going to be bouncing messages off from. Although we're not actually going to be bouncing messages off from, it's going to appear as though we're sort of bouncing messages off it. So I want to do a 192.168.1.39. And so in this case, I could have done a -pn in order to prevent Nmap from doing a ping of the system that we're actually scanning. And Nmap does a ping traditionally to determine whether the system is up, to see whether we actually need to scan it or not. Now, if I've pinged it, then that system knows about me. In this case, what I'm actually doing is I'm bouncing messages sort of through this system. And how I do that is Nmap actually sends messages to my target, which is the .39, with a spoofed IP address of the .1 here. And as a result, messages are going to go back to .1. So you may be wondering, if responses are going back to .1, how am I supposed to know whether the port is open or not? Well, the reason we know that the port is open is because we keep sending messages to .1 as well, and we'll check the IP identification header and determine how that identification number has been incremented. If it increments one way, then we know that the target didn't actually reply. If it increments another way, then we know that it got a different type of response. So based on how many numbers the IP ID flag or header field increments, we can make some determinations about how the target replied to it, because in between we keep checking the IP ID field and see how the field has actually changed based on the messages that we send and the messages that we send pretending to be them. And as a result, we end up keeping track of the ports that appear to be open. So you can see that we did this zombie scanner idle scan, and we bounced messages out appearing to be from this IP address to this IP address, and we did get the set of ports that are open back. And in this case, it looks pretty complete. It looks like the same set of ports that we got back when we did the SYN scan and the full TCP open scan as well. So you can see that if you pick the right host, then you can actually get some pretty accurate results. And when I say right host, I mean you need to find one that's actually not getting a lot of messages. If it's actually getting a lot of messages, then the IP ID header field is going to increment in ways that we can't predict. So it's called a zombie scan because the host that we're bouncing through is just kind of not doing much of anything. So it's a bit of a zombie. So if you pick the right zombie host, then you can get pretty accurate results on your target using that zombie host to mask your identity. And that's really the point of doing this idle scan, is you want the target, the real target, not to know about you. And so you use this other host that can't be tracked back to you to be able to bounce these scans through.